Hi. Today I'm going to tell you 100 sleepy facts about ice, perfect if you want to relax a bit and learn something interesting about this icy element. Enjoy listening. 1. Ice is the solid form of water. It forms when water cools below 0 degrees Celsius (32 degrees Fahrenheit). Ice has a lower density than liquid water, which is why it floats. Its unique structure creates hexagonal crystals that make snowflakes and frost. 2. Ice can exist in different forms called phases. Under extreme pressure and temperature, water molecules arrange differently. Scientists have identified at least 17 crystalline forms of ice. These forms occur naturally in planets, moons, and laboratory conditions. 3. Ice covers about 10% of Earth's surface. Most of this ice is found in glaciers, ice caps, and polar regions. Antarctica and Greenland contain the majority of the planet's ice. It plays a vital role in regulating Earth's climate. 4. Ice reflects sunlight efficiently. This property, called albedo, helps cool the planet. Polar ice reflects solar radiation back into space. Melting ice reduces albedo, which contributes to global warming. 5. Ice insulates water beneath it. When lakes or rivers freeze, the ice layer protects aquatic life. Water below remains at a stable temperature around 4 degrees Celsius (39 degrees Fahrenheit). This allows fish and other organisms to survive winter. 6. Ice forms hexagonal crystals. Water molecules bond in a hexagonal lattice. This is why snowflakes have six-fold symmetry. Temperature and humidity influence the shape and size of ice crystals. 7. Icebergs are large pieces of freshwater ice floating in the ocean. They break off from glaciers or ice shelves. About 90% of an iceberg is below water, making it dangerous for ships. Icebergs can travel thousands of kilometers before melting. 8. Ice can sublimate directly into water vapor. This process occurs without melting first. Sublimation happens in cold, dry conditions, like polar deserts. Snow can slowly disappear without forming liquid water. 9. Ice affects sea levels. Melting glaciers and ice sheets add freshwater to oceans. Rising sea levels threaten coastal communities. Scientists monitor ice loss to predict climate impacts. 10. Ice has unique acoustic properties. Sound travels faster in ice than in liquid water. Scientists use ice's acoustic behavior to study glaciers and icebergs. Icequakes are vibrations caused by shifting or cracking ice. 11. Ice is slippery due to a thin water layer on its surface. Pressure and friction melt a microscopic layer of ice, reducing friction. This is why ice is good for skating and sliding. Temperature affects how slippery ice feels. 12. Sea ice forms from freezing ocean water. It differs from glaciers because it originates from salt water. Sea ice can expand and shrink seasonally. Polar ecosystems depend on sea ice for habitat and hunting grounds. 13. Ice cores provide climate records. Scientists drill into glaciers and ice sheets to study past climates. Layers of ice trap air bubbles, pollen, and dust. These records reveal temperature, atmospheric composition, and volcanic activity over thousands of years. 14. Ice can be transparent, white, or blue. Purity and air bubble content affect its color. Thick, dense ice appears blue because it absorbs red light. Surface snow or bubbles make ice look white. 15. Ice protects plants and animals in winter. Snow and ice cover insulates soil, preventing deep freezing. Many small animals survive under snow in burrows. Ice also preserves seeds and plant structures. 16. ice expands when water freezes. Unlike most substances, water increases in volume upon freezing. This expansion can crack rocks, pipes, and containers. It is a key factor in shaping landscapes through frost weathering. 17. Ice can form on vehicles, buildings, and roads. Freezing rain or snow accumulation creates hazards. Black ice is particularly dangerous because it is hard to see. Engineers use salt, sand, or heating systems to manage ice. 18. Ice can form frost patterns on windows. Cold surfaces cause water vapor to deposit as ice crystals. Temperature and humidity influence the intricate patterns. Frost can create artistic, natural designs on glass. 19. Ice is used for cooling and preserving food. It slows bacterial growth and keeps perishable items fresh. Ice blocks, cubes, and packs are widely used worldwide. Ancient civilizations used ice harvested from mountains or stored in ice houses. 20. Ice has been used in sports for centuries. Ice skating, hockey, curling, and sledding all rely on frozen surfaces. Ice provides smooth, low-friction conditions for recreation and competition. Winter Olympics showcase ice-based sports globally. 21. Ice can exist in the atmosphere as snow or hail. Snow forms when water vapor freezes directly into ice crystals. Hail forms inside thunderstorms when layers of ice accumulate on rising water droplets. Both play important roles in weather and climate systems. 22. Glaciers are massive rivers of ice. They move slowly across land due to gravity. Glaciers carve valleys, shape mountains, and transport rocks and debris. They are also indicators of climate change because they advance or retreat depending on temperature. 23. Ice shelves float on the ocean but are connected to land. They form from glaciers flowing into the sea. Ice shelves act as barriers, slowing the flow of glaciers into oceans. Their collapse can accelerate sea level rise. 24. Ice can store oxygen and gases from the past. Air bubbles trapped in ice cores reveal historical greenhouse gas levels. Scientists study them to understand Earth's climate history. This information is crucial for predicting future climate trends. 25. Ice can bend and flow under pressure. Though solid, ice can deform slowly over time. This plasticity allows glaciers to move across landscapes. Ice flow shapes terrain, creating crevasses, moraines, and glacial valleys. 26. Ice can form in lava tubes and caves. These ice formations occur in volcanic or karst environments. Temperature and humidity conditions preserve ice year-round in some caves. They create spectacular natural ice sculptures. 27. Ice affects ocean currents. Melting polar ice changes seawater salinity and density. This influences thermohaline circulation, which drives global ocean currents. Ice plays a crucial role in regulating Earth's climate. 28. Icebergs can be tabular or irregular. Tabular icebergs have flat tops and steep sides, resembling tables. Irregular icebergs have jagged, uneven shapes. Their structure depends on how the glacier calved and the melting process. 29. Ice can erode landscapes. Glacial ice scrapes rock surfaces as it moves, forming striations and fjords. Rocks embedded in ice act like sandpaper. This erosion shapes mountains and valleys over thousands of years. 30. Ice can act as a reflective surface. Ice and snow reflect sunlight, reducing heat absorption. This helps maintain colder temperatures in polar regions. Loss of ice reduces reflection, contributing to warming. 31. Ice can be artificially made for sports and recreation. Ice rinks are frozen using refrigeration systems. Artificial ice allows indoor skating and hockey regardless of outdoor temperature. It has revolutionized winter sports accessibility. 32. Ice can form on plants and trees. Frost occurs when water vapor condenses and freezes on surfaces. Ice can damage leaves, stems, and fruit. Farmers monitor frost to protect crops and plan harvests. 33. Ice can float because it is less dense than liquid water. Water molecules form a lattice that occupies more space than in liquid form. This property protects aquatic life in freezing lakes and oceans. It is a rare example of solid being less dense than its liquid. 34. Ice can form pressure ridges in the Arctic and Antarctic. These ridges occur when ice sheets collide and buckle. They can be several meters high and affect sea navigation. Ridges also impact wildlife movement and habitat. 35. Ice can exist on other planets and moons. Mars, Europa, Enceladus, and other celestial bodies have ice. Extraterrestrial ice often contains frozen water, carbon dioxide, or methane. Studying it helps scientists understand planetary processes. 36. Ice can be used to preserve biological samples. Cryopreservation stores cells, tissues, and embryos at extremely low temperatures. Ice slows chemical reactions and decay. It is essential for medicine, research, and agriculture. 37. Ice caves can form in glaciers. Melting and refreezing create tunnels and chambers within glaciers. These caves can be dangerous but are spectacular to explore. Ice caves are temporary and change shape seasonally. 38. Ice can create unique sound effects in nature. Cracking glaciers, ice shifting on lakes, and icicles breaking produce eerie sounds. These noises are caused by stress, temperature changes, and expansion. Scientists use them to study ice movement. 39. Ice can trap volcanic ash and dust. Layers of ice capture particles from eruptions and storms. Ice cores reveal past volcanic events and atmospheric conditions. This data is used in climate and geological studies. 40. Ice plays a crucial role in the polar ecosystems. Animals like polar bears, seals, and penguins depend on ice for hunting, breeding, and shelter. Melting ice threatens their habitats and survival. Ice stability is essential for maintaining biodiversity in polar regions. 41. Ice can form naturally on rivers and lakes. When air temperatures drop below freezing, water surfaces solidify. This seasonal ice provides temporary pathways and recreation opportunities. Ice thickness varies based on temperature, depth, and currents. 42. Ice can be dangerous if too thin. Thin ice may crack under weight, leading to accidents. Authorities monitor ice thickness for safety on lakes and rivers. People are advised to test and avoid unsupported ice. 43. Ice can form glaciers over centuries. Snow accumulates, compresses, and slowly transforms into ice. This long process results in massive ice sheets and mountain glaciers. Glaciers store fresh water and shape landscapes over millennia. 44. Ice cores reveal pollen and microorganisms. Trapped particles provide insight into past ecosystems. Scientists study these to understand historical climate and biodiversity. Ice acts as a natural archive of Earth's history. 45. Ice can create spectacular frozen waterfalls. Water flowing over cliffs can freeze in cold weather. Layers of ice build up, forming natural sculptures. These frozen waterfalls attract climbers and photographers alike. 46. Ice can form on airplanes during flight. Supercooled water droplets freeze on surfaces. Ice can disrupt aerodynamics and affect safety. Pilots use de-icing techniques to prevent accumulation. 47. Ice influences ocean life. Algae and microorganisms grow on the underside of sea ice. They form the base of polar food webs. Melting ice affects nutrient cycles and marine ecosystems. 48. Ice can refract and reflect light, creating optical phenomena. Sunlight passing through ice can produce halos, sundogs, or sparkling effects. Crystalline structures scatter light uniquely. These phenomena are often observed in polar regions. 49. Ice can form under extreme pressure at the bottom of glaciers. Deep ice experiences stress that alters its crystal structure. This can lead to denser forms like ice 2 or ice 3 in laboratory conditions. Such ice behaves differently from surface ice. 50. Ice can preserve historical artifacts. Items trapped in glaciers or permafrost can remain intact for centuries. Archaeologists find ancient tools, clothing, and even human remains in ice. Preservation occurs due to low temperatures and minimal decay. 51. Ice can create icebergs from glacier calving. When a glacier reaches the sea, chunks break off. These icebergs float and drift with currents. Their size and shape can be hazardous to ships. 52. Ice can influence local weather patterns. Ice-covered areas cool surrounding air, affecting winds and precipitation. Polar regions play a crucial role in global climate regulation. Seasonal ice melt contributes to weather variability. 53. Ice can form icicles on buildings and trees. Dripping water freezes into pointed formations. Icicles indicate freezing temperatures and water flow. They can be dangerous if they fall but are visually striking. 54. Ice can support winter sports and activities. Skiing, ice skating, curling, and ice climbing rely on frozen surfaces. Ice conditions determine safety and performance. Snow and ice are central to winter tourism. 55. Ice can store ancient air samples. Air bubbles in ice cores reveal historical atmospheric gases. This helps scientists track CO2, methane, and oxygen changes over millennia. Ice provides a timeline of Earth's climate. 56. Ice can expand cracks in rocks through frost wedging. Water enters rock crevices and freezes, enlarging cracks. This process shapes mountains, cliffs, and pavements over time. Frost wedging is a key geological force in cold climates. 57. Ice can form on volcanic lava flows. Lava entering icy rivers or glaciers cools rapidly, forming unique ice lava structures. This interaction creates fascinating geological formations. Such events occur in polar volcanic regions and Iceland. 58. Ice can create frozen fog or rime. Supercooled water droplets freeze upon contact with surfaces. Rime forms delicate coatings on trees, power lines, and structures. It often occurs in mountainous and polar regions. 59. Ice can float in different liquids besides water. Saltwater ice is denser due to trapped brine. Ice in other liquids follows principles of density and freezing point. Understanding ice behavior in liquids is important in oceanography and chemistry. 60. Ice is essential for scientific research in polar regions. Researchers study ice to monitor climate change, ecosystems, and geology. Ice stations and drilling projects provide crucial data. Polar ice studies inform predictions for global environmental changes. 61. Ice can form on roads and sidewalks in winter. Freezing rain or melting snow creates hazardous surfaces. Black ice is particularly dangerous because it is nearly invisible. Authorities use salt, sand, and de-icing chemicals to improve safety. 62. Ice can influence coastal erosion. Floating ice and icebergs scrape shorelines, breaking rocks and soil. Seasonal ice movement changes landscapes over time. In polar regions, ice plays a major role in shaping coastlines. 63. Ice can exist in frozen methane or ammonia forms on other planets. Bodies like Titan have methane ice, while distant planets may have ammonia ice. These exotic ices behave differently than water ice. Studying them helps scientists understand planetary chemistry. 64. Ice can act as a natural reflector for lasers and radar. Polar ice sheets are used for scientific measurements. Radar signals penetrate ice to study layers, thickness, and structures. This technique helps monitor glaciers and ice stability. 65. Ice can cause frost heaving in soil. Freezing water expands in the ground, lifting rocks and soil. This affects roads, pavements, and agriculture. Frost heaving is an important factor in cold region engineering. 66. Ice can preserve fossils and ancient organisms. Permafrost and glaciers protect biological material from decay. Scientists have found preserved plants, insects, and mammals. Ice allows the study of past life and ecosystems. 67. Ice can create glaciers that shape valleys and mountains. Moving ice sculpts U-shaped valleys and fjords. Rocks carried by glaciers leave moraines and striations. Glacial landscapes are unique geological features. 68. Ice can create sea ice ridges and hummocks. When ice sheets collide, ridges form above and below the surface. These formations affect navigation and wildlife movement. Ice ridges are common in polar oceans. 69. Ice can affect freshwater ecosystems. Frozen lakes maintain a layer of liquid water underneath, supporting fish and other aquatic life. Ice cover protects against temperature fluctuations and predators. Seasonal melting replenishes nutrients. 70. Ice can be used for energy storage. Ice-based thermal storage stores cold for cooling buildings. It absorbs heat as it melts, reducing energy demand. This technology is used in sustainable urban planning. 71. Ice can form on power lines and communication towers. Accumulated ice increases weight and can cause collapse. Ice storms disrupt electricity and transportation. Engineers design structures to withstand ice loads. 72. Ice can produce icequakes. Glacier movement or sudden cracking generates seismic activity. Icequakes are monitored to study glacier dynamics and stability. They are natural indicators of ice stress and change. 73. Ice can reflect the changing seasons. Snow and ice cover signal transitions between winter and spring. Melting patterns indicate temperature trends. Ice coverage is a visual indicator of seasonal cycles. 74. Ice can support winter tourism and adventure sports. Ski resorts, ice climbing, and snowmobiling rely on frozen conditions. Seasonal ice boosts local economies. Safety and weather monitoring are essential for tourism. 75. Ice can form on aircraft wings and surfaces. Ice accumulation affects lift, weight, and control. De-icing systems are crucial for aviation safety. Pilots monitor weather to prevent ice-related hazards. 76. Ice can trap pollutants and dust. Atmospheric particles become embedded in ice layers. Scientists study ice cores to track human impact on the environment. Ice provides a historical record of pollution. 77. Ice can form in oceanic polar regions seasonally. Sea ice grows in winter and melts in summer. Its extent influences ocean circulation and climate. Polar ecosystems depend on this seasonal ice cycle. 78. Ice can create frozen waterfalls and ice formations. Cold temperatures turn flowing water into sculptural ice. These formations attract photographers and climbers. Ice structures are temporary and vary with weather. 79. Ice can generate reflections and optical effects. Sunlight on ice creates glimmers, sparkles, and halos. Polar regions often show stunning light phenomena. Ice crystals refract light in unique ways. 80. Ice is essential for studying climate change. Melting ice provides evidence of global warming. Glaciers, ice sheets, and sea ice are monitored using satellites and field studies. Ice data helps predict future environmental changes. 81. Ice can be used in cryotherapy for health treatments. Ice and cold temperatures reduce inflammation and pain. Athletes use ice baths or ice packs for recovery. Cryotherapy takes advantage of ice's ability to slow metabolic processes. 82. Ice can preserve food during transportation. Frozen ice packs and blocks maintain low temperatures. This prevents spoilage and bacterial growth. Ice is essential for shipping perishable goods worldwide. 83. Ice can form unique shapes in nature. Icicles, hoarfrost, and ice columns appear under specific temperature and humidity conditions. Each formation is influenced by airflow and water movement. These natural sculptures are temporary and fragile. 84. Ice can affect transportation in winter. Snow and ice create slippery roads, frozen railways, and icy runways. Vehicles and aircraft require special adaptations to navigate safely. De-icing and snow removal are critical for safety. 85. Ice can reflect sound differently than water. Sound travels faster in solid ice than in liquid water. This property is used in scientific studies of glaciers and ice sheets. Icequakes and cracking produce unique acoustic signals. 86. Ice can store freshwater for human use. Glaciers and ice caps contain the majority of Earth's freshwater. Melting ice supplies rivers and lakes. Humans rely on these resources for drinking water, irrigation, and industry. 87. Ice can act as a barrier to ocean mixing. Sea ice prevents direct contact between air and water. This influences salinity, temperature, and ocean currents. Ice plays a key role in regulating Earth's climate systems. 88. Ice can create hazards for marine life. Animals like seals and penguins rely on stable ice platforms. Melting or unstable ice can threaten breeding and feeding. Ice changes directly affect polar ecosystems. 89. Ice can preserve biological and historical records. Frozen organisms, pollen, and dust provide snapshots of past environments. Scientists study these to understand evolutionary and climate history. Ice acts as a natural archive. 90. Ice can form naturally in caves as stalactites and stalagmites. Dripping water freezes in cold caves, creating intricate formations. Ice caves provide unique ecosystems and tourist attractions. They are sensitive to temperature changes. 91. Ice can melt under pressure. High pressure lowers the melting point of ice slightly. This property allows glaciers to slide over bedrock. Pressure melting is a key factor in glacial movement. 92. Ice can exist in polar deserts. Even in dry regions like Antarctica, ice persists. Sublimation slowly removes ice without melting. Polar deserts highlight extreme survival conditions for ice and organisms. 93. Ice can affect global weather patterns. Melting polar ice contributes to changing sea currents and atmospheric conditions. This impacts rainfall, storms, and temperature worldwide. Ice is a critical component of Earth's climate system. 94. Ice can form in volcanic environments. Ice interacts with lava and hot springs to create unique geological features. Glacial volcanic eruptions produce jökulhlaups, or ice floods. Such events occur in Iceland and other regions. 95. Ice can influence human culture and recreation. Winter festivals, ice sculptures, and skating traditions depend on ice. Ice plays a role in art, sport, and seasonal celebrations. Cultural practices often revolve around frozen landscapes. 96. Ice can store methane and other gases in permafrost. Trapped gases are released if permafrost melts. This contributes to greenhouse gas emissions. Ice and permafrost are critical for understanding climate feedbacks. 97. Ice can form underwater in supercooled conditions. Liquid water below freezing temperature can suddenly freeze when disturbed. This phenomenon occurs in oceans, lakes, and rivers. Supercooled ice has unique crystal structures. 98. Ice can fracture and form crevasses in glaciers. Movement and stress create deep cracks in glacier surfaces. Crevasses are dangerous for mountaineers but reveal internal ice dynamics. They provide insights into glacial flow patterns. 99. Ice can influence polar human settlements. Communities in Arctic and Antarctic regions rely on ice for transportation and resources. Ice roads, hunting, and fishing are critical to survival. Changing ice conditions affect infrastructure and lifestyles. 100. Ice is essential for maintaining Earth's environmental balance. It regulates temperature, stores fresh water, and supports ecosystems. Melting ice signals climate change and affects life worldwide. Understanding ice is vital for predicting the planet's future.